Section 2.5 Inequalities Involving Quadratics, Part 1. The first part of solving quadratic inequalities is actually the same as solving a quadratic equation. But after we find our zeros, it's a little bit different. Let's take a look at example 1. Do you remember what the first part was? Well, first we set our quadratic equation equal to 0. After that, we factor. Once you have your factors, you set each factor equal to 0, and then you solve for x. And there we have it. We have our two solutions that make our quadratic equation 0. Now let's take a look at how to solve quadratic inequalities. Well, the first step is the same. We find the zeros. So we set our inequality greater than or equal to 0. We then factor, and finally, we find the zeros. So our zeros are 3/2 and -2, which are the same as the zeros we found in example 1. Now here's where it's a little bit different. I'm not solving for the equation equals 0. I'm not solving for 2x squared plus x minus 6 equals 0. I'm solving for 2x squared plus x minus 6 greater than or equals 0. That means that I'm solving for all the x values that not only make my quadratic equal to 0, but also it makes it positive. So the next thing we want to do to find out what solutions make this inequality positive is place your zeros on a number line. And I took the liberty to already do that. And then the next thing we want to do is we want to figure out whether we include -2 and 3/2 as our solution or we don't. Well, the inequality says greater than or equal to 0. That means that any x values that make our quadratic 0 are also included since we want it to equal to 0. With that being said, we write closed circles since -2 and 3/2 are included. Now let me explain that a little bit further. If you have a less than or greater than, we use open circles or parentheses. You can also place parentheses on the number line instead of open circles. If we have less than or equal to and greater than or equal to, we use closed circles. That means we include the zeros as part of our solution. So again, if you want to use brackets instead of closed circles, that's fine too. Step 3. Now I want to determine whether each interval or whether each solution in each interval give me positive or negative answers. I divided my intervals so you can clearly see them. You don't have to do this, but I did it anyways. And I just want you to think about what the first interval looks like. If you said -∞ to -2, then you are correct. And don't forget to write a bracket because we include -2. The second interval is -2 to 3/2. And finally, the third interval is 3/2 to infinity. Now, what you want to do is choose an x value in each interval to plug into your quadratic. And if you get a positive answer, then all the solutions in that interval will be positive, and the same for a negative answer. What do I mean by that? Well, let's take a look at the first interval, the -∞ to -2. Pick a number in between -∞ and -2, any number. -1,000,000, -100, -4, whatever you want. I'm going to pick -100. For the second interval, I'm going to pick 0 just because it's the easiest number to plug in. And then finally, for the last interval, I'll pick 100. Okay, again, you can pick whatever number you want in that interval. Okay. Now, the next thing I want to do is pick the number that I chose or that I picked. I'm going to plug it into my quadratic. And I want to see whether I get a positive solution or a negative. So let's start with my first interval, and I chose x equals -100. Okay, so we have 2 times negative 100 squared plus negative 100 minus 6. Now, you're probably asking yourself, Ms. Sandoval, why did you choose such a big number, a big negative number? Because now my calculations are going to take longer. Well, actually, I purposely chose a big number because I don't want to know what the actual numerical answer is. All I want to know is whether I get a positive or a negative solution. Now, the bigger the numbers that I choose, the faster it is for me to calculate that. So, for example, negative 100 squared times 2 gives me a big negative number, right? So the negative 100 minus 6 is not going to make a big difference. So I know that my answer is positive. So for the second one, I chose x equals 0. And again, we plug it into our quadratic. And once again, I don't really care what the answer is. I mean, I can tell right away it's negative 6 since we plugged in 0. But all I want to know is whether it's negative or positive. And then finally, we plug in x equals 100. And again, I'm not actually doing any calculation. All I'm doing is trying to see whether I'm going to get a positive or a negative answer. So in the first interval, we get positive. In the second one, we get negative. And in the third one, we get positive. And again, those come from the work that I did over here on the right-hand side. Okay. And if you chose in the interval negative infinity to negative 2, if you chose negative 3, you should have gotten the same answer. Or if you chose negative a million, you should have gotten the same answer. Okay, so now we have whether our answers in each interval give us positive or negative solutions. Now that we have that, we can figure out what our answer to our inequality is. Let's take a look at step 4. Now that you know whether each interval produces positive or negative answers, shade the intervals that make our inequality true. For example, in our inequality, 2x squared plus x minus 6 is greater than or equal to 0, which means that our solutions are all the x values that make our inequality. What do you think? If you said 0 or positive, you are correct. Okay, so we already know that we want all the values that make our inequality 0. And those are negative 2 and 3 have our zeros. And that's why we put closed circle. But which ones make our inequality true? Which one makes our inequality positive? Let's go ahead and shade those. Well, those are these intervals which we found in step 3. And now we're ready to write our answer in interval notation. So I'm just writing whatever I highlighted. So that's negative infinity to negative 2 bracket union 3/2 to positive infinity. And that is our final answer. So within these intervals are all the x values that will make our inequality true. Please join me for part 2. As in part 2, I'm going to give you shortcuts and how to do this a lot quicker. These problems don't take this much time. This one did because it's the first one and I was explaining to you how to do it. But in the next one, I'm going to show you a method that's a lot quicker.